Hi, and welcome to my video series on refactoring. In this series, I'm taking a very old C++ code base with pretty poor code quality and a lot of problems, and improving it using various techniques and tools. So in this first episode, I want to introduce the code base, talk about what the problems are and what I'm planning to do, and then do a first couple of improvements. All the code is on GitHub, so you can have a look for yourself if you want, and all the changes I'm making in these videos, I will also push them to this repository. Okay, so let's have a look at the project. So this code is from a game I made back in 2003, 19 years ago. And I was still in high school at that time. I had already had a little bit of programming experience, but I was still quite fresh and just getting more deeply into C++ with this project. And as we will see, this definitely shows in the code. But let's check out the game itself first. Okay, so the game is called Starfield Battle, and it's a space shooter game. So you have a spaceship and you need to fight these other spaceships that randomly appear and also shoot at you, and yeah, you're trying to destroy as many of them as possible without being hit yourself to score as many points as you can. Then if we get hit, then it's game over and we made a high score, or maybe you don't make one if you don't have enough points. And yeah, that's basically it. There's also a multiplayer mode. In this mode, 2 players can play at the same keyboard, and you compete for the highest score in a time limit. And then at the end, it shows you which player has won, and that's the multiplayer. Alright, now let's have a closer look at the code itself. So the project consists of 24 source files, and in total it's about 2,300 lines of code, which is at the time for me was pretty big, but is actually relatively small compared to the code bases I'm dealing with nowadays. And so that's why I thought it's a great candidate for this refactoring series, because it's so small that we can actually achieve quite a lot in a pretty reasonable amount of time. And the code is all C++ 98, although I was using Visual Studio 6.0 at the time, which is not exactly standards compliant. So there are some things here which actually aren't really standard C++ and won't compile on a modern compiler anymore, but we'll get to that. All right. And so this game is using the DirectX API for input and output, so for graphics, sound, and keyboard input, which means it's Windows only. And that's one of the things I'm planning to do in this video series, to make it portable and run on other platforms as well. But for now, we will leave it at that and just make various improvements to the code as it is. All right, and so this DirectX interface is kind of sort of abstracted with these 3 classes here, like the Direct Draw Manager and the Direct Input Manager and the DirectX Audio Manager. Yes. Right, so we have these 3 classes which kind of abstract the DirectX API, because the DirectX API is quite verbose. And then we don't have much here. We have some initialization function to clear the screen, flip the screen, which is, if you're familiar with graphics programming and double buffering, you usually render into a back buffer, and then you present this back buffer on the screen by swapping it with the front buffer, which is what you currently see on the screen. And yeah, then we have the input manager, and the audio manager. which is using the direct music API, both for sound and music. Okay, so these three classes are kind of the platform layer, or system interaction layer. Then we have a linked list class, which is, funnily enough, using a mix of German and English naming. So the code is generally in English, but here we have this class Knoten, which means node in the context of a linked list. And then we have this list class, which, it was at the time, it was not uncommon for C++ projects to have their own container classes. C++ had just been standardized. So, I mean, in 2003, it was around for a couple years, the standard C++, but when Visual Studio 6.0 came out, it had just been standardized. And as far as I know, the early implementations of the standard library weren't of that great quality. And so people preferred to have their own container classes. And so we have this linked list here, but it's not a very good one. I mean, on one hand, it's not at all type safe, so we can see that each node just stores a void pointer to whatever data it's storing. And then also it's mixing the iteration state and the list itself. So you have the pointers to the begin and the end, because it's a doubly linked list, but you also have the current pointer, which is actually more like an iterator, if you want. And then you have the stateful API to choose the next one or the previous one, or go to the first one, and so on. Right, so but this is more like a foundational class. Then we have the starfield class, which is responsible for drawing this moving stars flying by effect that you see in the background. So here we have these moving stars, and that's implemented by this class. Then we have a bunch of different classes for dealing with the enemies and the player and the shots and the explosion effects. So that's this sprite class, a sprite no list. It doesn't tell us much, this name, but we will see more about it later. Armed sprite, which inherits from sprite, as does this a sprite no list also. Then we have a class called sprite manager, which interestingly enough lives in a file called gamemanager.h. And this kind of mostly deals with managing the enemies and making them appear. We have a fx manager, which deals with the explosion sprites that appear when an enemy or the player is destroyed. Then we have main.cpp. And this is kind of where everything is tied together. And it's the biggest file at 814 lines. And it's also the messiest, I would say. So we have this main function, WinMain specifically, because it's a Windows GUI application. And this function is 651 lines long. And it's also full of this really deeply nested, complicated code, where you have just very deeply nested if statements and a lot of different things happening. And yeah, I mean, we have here 300 lines, a single if statement, and then the else block is another 102 lines. So yeah, this is quite messy and a bit hard to follow. But also the state is pretty complicated. Like, for example, you have these static local variables here, but then we also have global variables here, like running in game and so on. Okay, so that's a rough tour of the code. Now, I already mentioned a few things that are problematic about it, but let's have a closer look at this. So as you maybe already noticed, the organization is not very meaningful or clear. Like, we have some things that are pretty self-contained and make sense. So like this DirectX abstraction layer, it could be improved for sure, but it's overall relatively sensible. Then we have this list class, which has problems, but it's still self-contained and makes sense. We can look at this code and we can understand it, improve it maybe. And the star field is also fairly self-contained. But then we have these various sprite classes and the sprite manager and FX manager, and this is a bit more entangled. For example, this class is called sprite, and it's the base class for armed sprite and a sprite no list. But this class is kind of mixing fundamentals, like, okay, we have a sprite, so a graphic that we can position somewhere on the screen, but then it also does collision detection, which is fine because most things need it, but the explosions, for example, don't need it. But it also has this logic, like this function called bounce is actually the logic that makes the enemies move around on the screen. So that's super specific to only the enemies, but everything else also uses this class or uses it as a base class. So all of the moving things in this object, in this game, have this method, even though they don't need it. And then what's also interesting, so we are using classes, but we also have this type thing. So you could ask, well, why don't we have more subclasses? Okay, and then we have this sprite manager, which kind of does various things, but for example, it has this fire shot function. No, I think that's actually called from here. So this could be a private function, actually. Yeah, this fire shot is for when an enemy wants to shoot. And this, let's have a look at this, because that's actually quite funny. So we have this move and shoot function, which, by the way, has this Boolean argument move. So that's always also a red flag for me if you have a function and you have these kind of Boolean flags to slightly alter the behavior in weird ways, that then maybe this should be two separate functions instead. That would be much cleaner. Okay, but the point I was trying to make is, so we have this move and shoot function, and it at some point calls this fire shot function if the sprite do fire function returns true. And so that's the enemy deciding if it wants to fire a shot. And then this manager class actually fires the shot on behalf of the enemy, so to say. And that's okay. But what's interesting is, if we look at do fire, it's not in this class. Where is it? It's inline here. Okay. So what's interesting is this do fire function is stateful, and it also plays the sound effect. So you ask the enemy, hey, do you want to fire a shot? And then it says yes or no, but it also, if it decides that yes, I do want to fire a shot, it also already does the sound effect. And then it has some internal state to make this decision, which is updated. And then if it wants to fire, then we call this fire shot function. Yeah, so the logic is a bit kind of all over the place. And then, of course, we, as I already showed, we have this huge main function with this very complicated logic, and that's really kind of hard to follow. And this really should be structured much better so that the individual pieces are clearer. Okay, so that's in terms of the structure. Now, there's other problems as well. And I'm just going to show a few. So for example, there's a few header files where we have these external declarations at the end. And this actually, I think at the time, maybe I didn't fully understand how header files work, because so these are in several of the header files. Armed sprite has this also. So here in armed sprite, we have this. Here we have this. And so really the proper way to do this would be to have a single header file that does that has these declarations, and then all of these files should include that header file. But for some reason I did it this way. And then also these are always seem to be outside of the include guard. So we are using include guards, and for some reason normally you put these at the very top of the file, like so, right? And make them include the entire file. But for some reason they are only partially here. They only cover parts of the file. So for example, they don't include, they don't incorporate these other includes, which isn't really a problem, but it makes the preprocessor do more work than it needs to, I think. Okay, so we can see there's some aspects of not really applying best practices properly. And there's a lot of that actually. So, I mean, overall, this code is using some C++ features, namely classes, but mostly it's really more C code, C-style code, procedural code with a little bit of C++, so C with classes, if you will. And this becomes very clear if we look at how string manipulation works. So all the string manipulation is using the C standard library functions like string copy, string length, string set. And it's very low level. For example, here we have some code for when you enter the high score. And so it's doing things like manually setting the null byte to terminate a string and this kind of stuff. So it's very low level, very error prone. And it's not making use of the facilities that C++, or the features that C++ provides, the more higher level features, like the stat string class or anything like that. So it's just doing it in this very low level way. File IO is also done using the C API, which, I mean, is fine, but also a bit more error prone, potentially. For example, you need to manually make sure that you close your file handles, whereas if you use std fstream, then that's done via RAII. And that brings us also to the memory management. So we can see there's a delete here in the destructor. So this code is using manual memory management with new and delete. It's not using smart pointers or anything like that. Smart pointers did exist at that time. So, I mean, in the standard library, you only had auto pointer, which is kind of problematic. But you did have boost was around at that time. And also in code bases, people did make their own smart pointer classes. So it wasn't like smart pointers didn't exist, but you had a lot of code also that was still using manual memory management at the time, and so this is no exception. And so manual memory management is quite error prone and really hard to get right and more verbose. And yeah, it just increases the cognitive load of understanding the code, but also very, very likely there are mistakes here and memory leaks as a result. Something else we also see here is this void in function declarations. And this is something that you would commonly see in old code bases, but it's actually in C++ not necessary. So the thing is, in C, there's a difference. In C, if you declare a function without arguments and you don't put the void, then at the call side, the compiler will actually accept any combination of arguments. So it doesn't really do any checking. And so you won't get the compiler error, but then you will get undefined behavior at runtime. So you don't want that, so you put this void. But in C++, it's different. In C++, if you just put empty parentheses, and then that's a function that takes no arguments, and the compiler will complain if you try to pass arguments to that function. So that's fine. But yeah, I mean, a lot of people came from C during that time, and from C to C++, and so they carried over this habit of putting the void into an empty function declaration, even though it's not necessary in C++. And so when I was getting into C++, I was probably using sources that also had this style, and so I adopted it. So that's something we can change. It's not really a problem, it just makes the code a bit more harder to read and surprising for a C++ programmer. Now, I mentioned the linked list is stateful and also untyped, so it has this void pointer, and it's your responsibility as the client of the list to make sure that whatever type you store in an element, you will later interpret it as the same type. And so that could be improved easily by using templates, for example, but that wasn't done here. Right, and also we can see here some non-idiomatic constructors. So normally in C++, you would, when you do a constructor, you use the initializer list. And that's not done here. We just assign to the members within the constructor body, which in this case, because these are all trivial types, primitive types, pointers, so it doesn't really make a difference. But if you have some object member that's expensive to initialize, for example, then you definitely want to do that in the initializer list, because otherwise it's going to be initialized once and then a second time when you assign to it, which is more expensive. This is also something we see a lot, like this Boolean expression that can be simplified a lot. Well, not this one, sorry. So here we have if something, then return true, else return false. And we could simplify this to just return the Boolean expression, and then we don't need any of that. Right. So to summarize, the code isn't really idiomatic C++. It uses manual memory management, which is error-prone. It doesn't really take advantage of any C++ features. It's generally much more complicated than it needs to be, like with examples like this. But also if we look at this argument list, for example, that's a lot of arguments and they are not even named here in the declaration. So you need to go to the source file to see what they are. Maybe introducing some struct to pass these arguments as a group would be nice here. The logic is quite complicated and hard to follow, especially with things like these. We have C-style low-level string manipulation, where we, which is also error-prone and harder to understand. We have this gigantic main function, which is also just super complicated and should be broken up. We're generally using define instead of constants and not using enums, for example. There is this thing here, player is hit, player scored. This could be an enum. So yeah, just not making good use of the available language features. And finally, I want to show something about this linked list. So I also already mentioned that it has some issues, but if we look at how iterating over this list looks like in the client code, so that's in the sprite manager, for example. So we first need to select the first node. Then we iterate. We get the current entry. We have to do a cast because it's the void pointer. Then we can do the actual logic that we want to do, which is this. And then finally, there's also this. And I'm not sure why this is here, because I would expect that this while condition should be enough, that once you get to the end of the list, the while loop should abort. But for some reason, there's also this and this is the case in everywhere where we iterate over something. Here, this is a great example also. So we have a lot of code, boilerplate code, just to do the list iteration, when ideally it would be something like this, right? Cool. So that's an overview of the problems that I saw with this code when I was looking through it. Now I'm going to be using the CLion IDE, and because it's very convenient for refactoring, it has some built-in refactoring tools, and it integrates clang-tidy, which is a static analysis tool that we are going to use, and also has some analysis of its own. And so that's quite convenient. You can do all these things that I'm showing without CLion, and it's a paid product, so you might not want to use it. But yeah, I'm going to use it because it's convenient. All right, and so I did already run this inspection. So you can do code, inspect code, and then it runs all this analysis. And so it found 5 errors, 716 warnings, and 1 weak warning. So that's quite a lot of warnings and errors. The errors are because, as I mentioned, the code is actually not standards compliant. It does still compile in Visual Studio, because Visual Studio, as long as you don't disable it, still allows various non-standard constructs. And so for now, we are still compiling in that mode, but we will change it so that we are standards compliant, and then these errors will go away. But so let's have a quick look. So there's a lot of unused code, for example, that we can see. For example, this show muzzle is never used. So, and as you can see from this commented out code, I believe I probably wanted to implement some kind of muzzle flash effect, but then didn't finish it and just left the unfinished code in here. Yeah, so there's a lot of unused code which we can get rid of to reduce the lines of code. We have clang-tidy, which gives us a lot of helpful warnings. For example, constructor does not initialize these fields, shot data, show muzzle. So there's a potential undefined behavior here where we maybe don't initialize something. Redundant void argument list and function declaration. That's that thing I already mentioned that comes from C. Narrowing conversion. Yeah. Use null pointer. So we are going to apply all or most of these checks. So let's look at them later. And finally, we have this data flow analysis, which is also interesting because it has these things like unreachable code. I mean, okay, that's an easy one. If you do a return, then you don't reach the break. Okay, fine, fair enough. But there was more interesting stuff like this, for example, where it says that this code is never reachable, which is interesting because, yeah, and that makes sense actually if you think about it, because we set this pointer lpdd7 to null at the beginning of the function, and then we check if it's null. So that's obviously always going to be true because none of the code here is changing that pointer. So this code is basically meaningless. And it also highlights things like condition is always true. I don't know why it says no longer valid. Oh, I guess because something triggered clang-format, and so that code is already reformatted. That's something I still want to do. Yeah, let's not do that. Okay. It seems very, very keen on always doing that. Okay. We will do clang-format in a second. But yeah, so we have things like conditions that are always true and this kind of stuff, which is quite useful. Okay. So yeah, the very first thing I want to do is to run clang-format, just to get the code a bit more consistently formatted and a bit more readable, because there are some things here which are quite long. So it definitely doesn't respect any line length limitations, and we have these things here where various expressions are just all on one line, or things like this, which is really hard to read. So by applying clang-format, that's going to be improved. All right, before we do that, let me quickly show you what I've already done. So I didn't make any substantial changes to this code yet, because I want to record all of that on video. But I did spend some time getting it to compile at all and getting it to run so that I'm able to show it in these videos. And so let's look at the Git history. So this is the original source, completely unmodified, the way I found it on an old hard drive. And then I added some of these DirectX headers just because it's not really, this SDK isn't available for download anymore. And yeah, I just wanted to make it simpler to build this stuff. And it's only, in the end, I removed some of them later because I realized I only need these two. So yeah, that's just that. So this code was using Visual Studio 6.0, as I said, and so it had the corresponding project files. And I at first tried, Visual Studio has this feature where it can upgrade old Visual Studio projects to a newer format. And I tried that at first, but the resulting solution didn't really work, so I did it by hand and made a new Visual Studio 2022 solution. And then I did have to fix a few compiler errors, but it's actually was very little because Visual Studio still has this permissive mode by default, where it will allow various non-standard constructs. Okay, and so all of these errors were of the same nature, namely you have a for loop, and then the loop variable I is used after the loop. And so I guess in Visual Studio 6, the scoping rules weren't implemented properly yet. And so you were able to have this for loop where you declare the loop variable, but then this loop variable would actually be valid for the scope outside of the loop as well. That's not the case anymore in modern compilers. And so we have to change it so that we declare the variable before the loop. And so I did that for all these cases where this was necessary. And that's really the only change the only real functional change I did to the code. Also had to fix this resource file, which is for including the icon into the executable to make it look like this. And this code, otherwise I would need to install MFC into my Visual Studio, which I don't really need and don't want. And so if we remove everything except for this one declaration, then it just works without MFC. Okay, content readme, dxwnd. I did convert the encoding to UTF-8, converted the line endings to Unix style, and added a new line at the end of the files, because otherwise you get this thing from Git when you look at diffs and stuff. But these changes shouldn't have any impact on the functionality of the code. So really fixing these compiler errors is really the only change I did. And yeah, here we are. And so now I want to run clang-format. And so I already have a clang-format file here, which I've just taken from another project of mine, and I'm just going to use that unmodified. So let's run clang-format on all the code. Just like that, pretty quick. And now everything is formatted with clang-format. Interesting. I don't know why it formats the include guard in this way, but I guess it does. Right, so I'm just going to commit that. Cool. Okay, and now every time we save a file, CLion is automatically going to apply clang-format to it. So if I change the formatting here and then save, puts it back. Cool. So let's see if that still compiles and runs. Yep, looks good. Cool. All right, so that's our first step, clang-format. Now, I should also mention, I didn't commit this yet, but in order to use CLion, I needed to add a CMake project. And I do want to change this a little bit before I commit it, because this file was auto-generated from CLion and then I modified it a little bit. Okay. So first, I don't need this to be indented quite as much. And I don't need these files here in the list of files. So yeah, I mean, it's a pretty straightforward CMake file. So we actually need only version 3.21. That's the first version that supports Visual Studio 2022. And we want it to be an error if the version is older. We declare the project. We say we are using C++11. I do want to use C++20, but for now, I left it at 11. If you set the standard to 20, then Visual Studio stops using the permissive mode by default, and then you get compiler errors with the code in its current form. So for now, I'm going to leave this like this. I do these actually, I want to have them per target. So these are the include directories. For the target, and we do need this DirectX directory and the current source folder. I think this should be, let's use this instead of the dot. So the dot that was auto-generated by CLion, but I think this is a bit more robust to do it like this. Okay, we have the list of files. We say Win32 because we need it to be a Win32 GUI application because it's using that WinMain function. And then we need to link to a few DirectX libraries. And let's maybe put these all on a line of their own, so it's a bit easier to read. Right? And so these are part of the Windows SDK, so you don't need any find package or anything. You just specify them, right? And then we also, this is another quirk of DirectX, we need to provide this init GUI preprocessor definition. Otherwise, it's not going to compile correctly. And we want the executable to be named Starfield Battle with a space, because that's how it was originally. And so we need to use the set target properties because the target name itself in CMake cannot contain spaces. Okay, so I think this is pretty good. I do want to add some more. And this here also, this is a bit, isn't quite as I would like it to be, but basically the issue is we have the assets, so the sounds and the sprites, and also this menu BMP, logos BMP, here in the top level directory at the moment, and we need the executable to be run in this directory in order for the game to find all these resources. And so right now I'm just setting the CMake output directory to the current source directory, which makes the executable appear here. And then it's also being run from here. The alternative would be to add some copy file command to CMake to make it copy these files into the output directory, which would be cleaner, because then right now, if we were to make a release build, it would override this executable. So this was just a quick dirty way for me to get it to work, but ultimately we do want to use this copy file approach, I think. Okay, but so that's our CMake file, and let's see if it still builds. Target include directories. That's right. I do need to specify that these are private. And so let's also do it like this again for consistency. Private directx. Okay. Oh, and actually, why do I don't need two directives? I just need one. I can list both of these in here. Okay, let's try that again. It's building and it's running. Cool. Right. There's also a race condition or something where it sometimes fails to start, which I know a workaround for, but haven't properly figured out what the issue is yet. But so this is kind of expected that sometimes it won't run, sometimes it will. Yeah, now it does. Okay, cool. But so we have our CMake file, so we can also commit that now. And I should probably, well, I could add these to the git ignore, but I really want to do this copy file approach. So for now, I will just leave them like this. Okay. Cool. All right. Now we are in a pretty good place. We have clang formatted the code. It's a bit more readable now. I'm guessing that doing the clang format probably increased the number of lines of code. So let's check. Indeed, we have about 330 additional lines of code now, which yeah, maybe seems like a lot, but on the other hand, it just shows how much some of this code was yeah, just doing these really long lines. And where did we have that? I thought it was, yeah, like so these things were just on a single line or on 2 lines or something. So that's nice that they are a bit more broken up like this. Cool. So let's see. Add CMake project file and format code with clang format. Okay, so now we are in a pretty good place, and now I do want to start fixing all these static analysis problems. Now, because of the clang format, some of these line numbers aren't right anymore, so I'm going to rerun this inspect code. All right, so now we should have these line numbers again. Condition is always true. Yep. Cool. All right, so now we want to work through these and fix all of these. And then I also do want to increase the compiler warning level and also fix any warnings that we get. But let's start with removing all of the unused code, because there's actually plenty. So let's see. Unused global declaration. And so we had this here. Function other shots is unused. Field show muzzle is never used. And what's nice is that CLion has this button here where I can just say delete. And then it deletes it for me. And it shows me that it's being used in 2 places, but this is always commented out. So let's say do refactor. And what did it do? It removed it. Cool. So I guess I can also remove these comments now. And there was this other one that it had. Right? Short list delete. Here. Okay. Cool. So we removed this show muzzle thing, then function other shots is never used. Let's also save delete that. And it just deleted it. Cool. Same with get shot list. Not used. So let's delete it. And it's gone. Sweet. We don't care about these direct music header files, or we don't want to change anything. Cool. This add function that takes a node is not used. That's good, because it's kind of weird, because the client would need to allocate the node, but then the list itself would deallocate it, so that's a bit fishy. So yeah, it's good that this function can be deleted. Same with this. That's interesting. I mean, I'm kind of here, I would say this actually should stay in, because we're maybe not using it in the code, but it is part of the API of a doubly linked list that you can navigate forwards and backwards. Now, I guess this is a good indication that maybe a singly linked list would be fine, because if we're only ever iterating forward. Yeah, but I'm gonna leave this in place for now. Replace current, however, I mean, sounds like it could be useful, but yeah, let's also leave that in, because it's also kind of part of the API. Cool. Can fire is never used. Well, let's delete that. And it finds one reference. Aha, right. And it's once again commented out. Cool. So let's do refactor and let's get rid of this comment. Sweet. Now, what else? That's all the unused global declarations. Unused include directive. Include system is not used. That's very nice that it detected that. So, well, let's delete it. Unused macro. Okay, well, yeah, this is in the DirectX code, so we don't really want to do anything about that. So that's already it. Interesting. I think I can say exclude. Yeah, we don't want these. These third-party files. Cool. So now it only has the listing. I know that there is more unused code, but it doesn't seem to find it. But so if we look at this direct input manager, then it has all these things, keyboard, mouse, joystick, but the game is only ever using keyboard input. So we can actually, like if we look at, for example, in a joystick, it's not used here. Init mouse is not used. Init keyboard is also not used, but I guess it's private. Sorry. Wait, what actually is public? Init and get input. Okay, right. And in it, you are passing in this variable use keyboard. And so there's, again, this could be an enum. But we only ever use keyboard. So I don't think we ever do use mouse or use joystick. Let's make sure. Yeah, it's not used in client code, and probably same thing with the joystick. Yeah, same thing. So we can get rid of that. And then joy tolerance is also joystick related, so we can get rid of that. We can get rid of init joystick, init mouse, mouse input, joystick input, joystick callback. We don't need that. Current device, if I recall correctly, is also just used to track what we are currently using. So since we only have the keyboard, we can get rid of that. And then for now, I will leave this parameter so that I don't need to touch the client code. But once we get this to compile, then we can get rid of that as well. And so then we don't need to switch. We just do init keyboard and that's it. Same here, get input just turns into get keyboard input. It's also funny, right? You have this key action map parameter, but it's only relevant for this use keyboard case. So it already indicates maybe you would want to split these up differently or something. Yeah. So this code actually now becomes a trivial forwarding function, which means we can also inline get keyboard input into that function later. But first, let's get rid of these other ones. Get mouse input, we don't need. Get joystick input, we don't need. Init keyboard, we do need. Get scan code, sure. There's something. Init joystick and init mouse, we don't need those. Get scan code, yes. Flush. And flush, it's only using the device to check if it's joystick. So again, we can ignore this argument and then remove it. And we don't need this enum joystick callback. Cool. So that's that. Let's see if it still builds. And it does. Cool. So we've removed quite a bit of code. All of these removals were code that the CLion static analyzer detected is unused. This one also, this one. It did not, however, detect this stuff. So we did that manually. It's still compiling. Let's see if it still runs and works. Yep, seems good. Still working. All right, cool. So that should bring our lines of code down again because we went up due to the clang-format, but now we are back down to 2400. So now we are still above the original line count, but by less. So that's good. So let's remove unused code. And now as a result of this, we can do a further refactoring, which is that this get keyboard input can now be inlined into the get input function. Let's do just that. And I wonder, this init keyboard, I mean, it's a whole bunch of code, so it's actually fine for that to be a separate method. Cool. So let's again see if we are still compiling and running. Now we hit the race condition. Let's try again. Yep. Seems good. Cool. All right. So that should save, well, just very few. Lines, but should also save a few more lines. Yeah. Okay. So that's that. Now let's have a look at what else do we have here. We have functions. Function draw hides a non-virtual function from class sprite. That's true. And actually, what's interesting about this is that it's just calling the base class function. So we can actually just remove it. And that's going to clear this warning. Cool. All right. So we fixed that. Then we have general. Empty declaration or statement. Ah, well, that's the third-party stuff again. So let's exclude that. Clang-d errors and warnings. Warning. Ah, yeah. And so this is what I mentioned about non-standard constructs that Visual Studio does compile. So we have this function error, which, can I jump to that? Yeah. Which takes a non-const char pointer as string. And then we have a literal string literal here when we call this function. And you cannot actually use a string literal as a non-const char, which makes sense because the string literal kind of lives in the executable binary, and it's not really something you can modify. So const char pointer is the only thing that really makes sense. But Visual Studio allowed non-const and also allowed binding R values to non-const references, which is also non-standard. And so because of the permissive mode of Visual Studio, it's still currently compiling these things, but it's not correct. So now that should be fixed by changing the declaration. So let's see, is it still built? Aha. Linker error. Why? Ah, that's right, because I do also need to change the declaration of this error function. So I changed this error function to take a const char star, but there's this declaration here which needs to be adapted. Cool. All right, still building. Good. And maybe let's inspect the code again. Cool. Then we have 3 warnings here. Declaration shadows a field. Aha. So we have a member variable called maxfx apparently, but are we using that anywhere? I wonder, because if not, then we can just delete the member, and then yeah, we are using it here. Okay. yeah, and actually it's doing and this is also interesting. It's assigning to the member variable inside of this array indexing operation. That's yeah, a bit cool. I mean, really the proper solution is to rename parameter. Well, I would like to rename the field, not the parameter, the member variable. So let's rename, refactor, rename, and let's put this m underscore prefix, which I saw already being used elsewhere in this project. So that should fix the shadowing. Because, yeah. Yep. Cool. And then this, same warning here, lpdds. Right, makes sense. So we can rename that one as well. Maybe we should rename all of them while we're at it for consistency. So, oops. And then sprite array, rename. And fx number. Okay, so now all our member variables have this m prefix, which means that we have this shadowing not anymore. Here again, play sound effects. Again, we have this issue with taking a string, accepting a string literal, but as a non-const. Can I go to declaration? I guess not anymore because I changed it. Declaration. No, yeah. Okay. DirectX Audio Manager. And let's actually do this for both of these. Add background music, add sound effect, play sound effect. Add sound effect, add background music, and play sound effect. Did I catch all of them? Oh wow, it did the renaming in this commented out code. That's interesting. Okay, we have this, we have this, we have this, we have this, we have this. I guess I'm going to fix all these string problems, string literal problems first, and then I'm going to deal with this okay, file name. Right, so we have this array of file names, which is declared as non-const char, but we now are trying to assign a const char to it, so that's why it fails. Okay, now it builds. Cool. So yeah, let's try to fix all of these string literal issues, and then we can take care of the shadowing. Set data. Here we are also passing in a file name. So we want that to be const, and then this also needs to be const. And that should fix those four. Non-portable path to file windows.h. Yeah. needs to be uppercase. I'm also actually not sure why we even include windows.h. I guess because we want bool. Yeah, that's right. So yeah, this code base generally is using this bool type def from windows.h, which we can replace with the built-in bool, and that's going to be better. And then we don't need this header file here either, but let's do that later. Cannot delete expression with pointer to void type void star. That makes sense. So if it's a void point, what delete needs to do, in addition to deallocating the memory, is also calling the destructor. And if it's a void pointer, it doesn't know what the destructor is. So that's kind of an inherent problem with the design of this linked list. I'm going to ignore it for now because we are going to replace this linked list with standard containers anyway, and then it doesn't matter anymore. Okay, we have again the case of windows.h. Sure. And then we have more of these. And a couple, we have deprecation warnings for C standard library functions that are unsafe, and more shadowing. But let's fix all of these first. And so I'm guessing it's all these calls, which should be fixed now, because now we are taking a const character. So this one we still need to fix, the init, but I'm guessing that these are already fixed by the changes we just did. Set shot data. So that one we may also need to fix. So it's set shot data, and yes. So we want that to be const. Sprite.h. We want that to be const, and then again the sound, the member, to also be const. Okay. So that should fix that one. And then we have this init function, and which takes a search path, which we also want to make const. And then same here. Cool. Okay. So let's commit all these changes to fix the string literal issues. So we want this. This is another change. This draw stuff. We want this. We want, this entire file. We want this entire file. We want this. This was dealing with the shadowing warning, so we don't want that in the current commit. This is also something else, We do want this, and we do want this. Fix passing string literals to non-const char star. Cool. Then we can also commit this windows.h stuff. And now let's see, so that should fix all of these. The shadowing stuff, maybe we will look at that later. I wonder if now we can actually build in C++20 mode, which, as I mentioned, should disable the permissive mode of Visual Studio. So now if I compile, should rerun CMake. It says build finished. Let's make sure. Yeah, I think. Cool, so that is working now. And I think just to demonstrate, so if I turn this back to how it was, then we should get a compiler error for that. At least when I tried it earlier, I think that's what happened. Yes. Excellent. So now it's saying that it cannot convert a string literal into a non-const character pointer, which is what we want. Awesome. So now the code is, at least as far as Visual Studio is concerned, standards compliant. We are not building in permissive mode anymore. Cool. We also removed this draw function override, which was not overriding a virtual function and anyway was just calling base class function. So remove unnecessary function. And then, okay, this, instead of doing the renaming inside of that comment, I'm just going to remove the comment. And while we're at it, we can also remove this commented out code. Cool. So that's just removing some commented out code. And then this here was renaming the members to avoid shadowing warnings. Okay. Cool. And we can build in C++20 mode. Very nice. Okay. So now we can get to the clang tidy warnings. I mean, there's also still this data flow analysis, which we can also fix. So we have the break here, which is not reachable because there's a return before. Then we have this here, which I discussed earlier. So this else is unreachable because we are always setting this to null. And so in fact, we can actually just completely eliminate, wait, what just happened? That's weird. Cool. So yeah, we can get rid of this if statement, and that should also fix that warning. Condition is always true if running and in game. So that's interesting. Condition is always true. I don't know how it determined that, but I guess in game set to false. In game and running are set to true. In game and running are set to true. Initially running is true and in game is false. But here it's saying that the condition is always true. Interesting. I guess, yeah, I'm not sure why it says that. Unreachable code, this one we can just remove. Condition is always true. It says this again, so yeah, maybe that really is the case. Condition is always true. Condition is always true. And this one I think makes sense. I looked at this one earlier. So we are saying here, if running and not in player die sequence, else if player die sequence. If running and not in player die sequence, else if player die sequence. 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 Else if player die sequ And I guess it makes sense that, yeah, if we are running and not in player sequence, well, in theory, it could be that we are not running, but in the player sequence, but that's probably not happening in practice. So I guess we could change this to just be an else. But I'm gonna leave it like this for now because I want to understand it better, how it determined that this condition is always true. Okay, so let's commit these changes that we did, removing unreachable code. And let's see how we are doing now in terms of lines of code. We removed a couple more lines. Still more code than before the reformatting, but that's okay. Okay. And yeah, I think that's gonna do it for today's video. Really just getting started. There's obviously a lot more to do, but yeah, we already made some improvements. And I'm going to push all of these to the repository. And yeah, next time I'm going to check out the clang tidy checks that you can see here and go through these and fix all of these, or rather let clang tidy fix them, because that's the nice thing about clang tidy, that it can also automatically fix many of these things. Okay. That's it for today. Thanks for watching, and I'll see you next time.